Allison Shear, and I'm the counselor here at Vine Grove Elementary. And tonight we had our family engagement night. We have the book fair going on in our library. We also had the Science Center from Louisville here tonight, and they did an Ion Jones chemistry presentation, had some fire, had some explosions, talked about elements and chemistry. The students were really entertained with it. Just encouraged our parents to come out tonight and get involved, and a big push for science, especially in those intermediate grades, but there were things for the little ones as well.
And we're flying over to Canada. Beautiful architecture there, and we will discover the Raiders of the Hidden Wavelengths. All right, so we've got another clue in my dad's journal here. He says, a form of light you cannot see. Its nickname is UV. Does anybody know what that is? What's UV? Yes. Yep. Ultraviolet. That must be what he's talking about. Ultraviolet, that's right. Okay, so that's light we can't see. Let's talk for a second about visible light, the light we can see. We've got some visible light going on in this room here. It looks white, but fun fact, it's not actually white. Does anybody know what color white light really is? Yes.
Yellow?
Yellow, that's correct, but it's not just yellow. Yes. Orange is also orange, yes, up top. That's right, it is all the colors of the rainbow. Red, orange, yellow, green, blue, indigo, and violet light all mixed together to form white light. Now, you notice that violet was all the way at the end of that list. And ultraviolet is so far on the end of that list that we can't even see it. If we were certain kinds of insects like bees, they can see ultraviolet light, but we can't. Now, even though we can't see it, that doesn't mean that it can't affect us. So does anybody know what would happen to me if I just went and hung out in front of some ultraviolet light for a while? Yes. That's right, I would get a sunburn, right? Especially if I didn't have sunblock on. So ultraviolet light is what causes sunburns. It can also damage your eyes if you're not wearing sunglasses. So we need to protect ourselves from that UV light. Now, I have been devising an armor to protect myself from ultraviolet light, but I'm going to need a victim, a volunteer to help test that armor. Yes, you, all the way to the top in the white. Come on down. All right, and now what is your name?
Lily.
Lily, all right. Lily, do you have insurance? You know what, never mind, you're gonna be fine. All right, so come over here to my travel case here and we will get you set up with your UV. Oh my God, snake! Oh my God. Oh my God, I hate snakes so much. Oh my God. Why does it always have to be snakes? You barely even flinch. I'm impressed. All right, let's get your armor going here. Here is your ultraviolet armor, complete with chainmail. Now here, help me put it on over your head so I don't hit you in the face with it. There we go. All right, now you're going to need some safety glasses. Go ahead and put those on. Can you fit them over your normal glasses? All right. You'll need this completely useless plastic helmet. There we go. Whoops. Let's grab that. You can't be without this. After all, it's completely useless. Now, no adventure is complete without a whip. There you go. All right, so here's what we're gonna do. You are gonna come back over here and stand in front of the black box of doom. No need to worry, it's just a doom box. Come on, back over here. All right, so you are gonna stand right here, and I'm going to turn on these ultraviolet lights. And hopefully, instead of Miss Lily catching on fire, that armor is going to protect her. Now, we're going to leave her there for a minute while she is subjected to this. Right? It doesn't really look like much. Remember, we can't really see ultraviolet light. We can only kind of see a little bit of that purple, okay? Now, if one of you was a bee and I was shining this at you, you'd be like, oh my God, it's so bright. It is a very energetic form of light. So right now, all of that energy is hopefully hitting Miss Lily's armor. And here's how we know if it worked or not. Nothing can take in energy without changing in some way, right? Remember how we talked about water can absorb that heat energy from fire, but it turns into steam. So we're going to be looking for something to have changed about her armor to know whether or not it protected her from that UV light. All right, let's take a look here. Let me turn it off. All right, and Ms. Lily, go ahead and let's step out and show everybody what your armor looks like now. All right, let's go into the middle right here. What do you guys see? Is her armor the same? No, what happened to it? Yes. That's right, it changed into all the colors of the rainbow. So those special beads on the outside, they absorbed that UV light and it changed them. It changed all those molecules inside of it and changed the way they reflect light and change their color. Pretty cool, right? All right, now let's give Miss Lily a round of applause for being such a brave volunteer. It's so much easier when they survive, right? It's a lot less paperwork for me. All right, let's go ahead and put your stuff back in the case here. Go ahead and put that. Oops. And get the armor off. It's heavy, right? It's real chainmail. All right, and you may go back to your seat. One more round of applause for Miss Lily. Excellent. All right, so we have learned quite a bit about ultraviolet light. Let's review. No, it's time to go back to the map and go to our next destination. What do you say we travel to Australia and visit the Bubbling Badlands? That's right, let's get our airplane wings ready. Here we go. Heading down the mountain to the Bubbling Badlands. Oh my gosh, that kangaroo is after me, you guys. It's after me. Oh, okay. Phew, that was fine. All right. Now, I have a very serious question for everyone here. Who in the audience is good at releasing gas? See some hands, see some hands, see some finger pointing. Interesting. Oh, I see what you guys are thinking. No. I mean, who's good at exhaling gas? All right? So remember, this is another one of the compounds we talked about, carbon dioxide. That is the gas that we exhale. Carbon dioxide is found in lots of places, right? It's found in our lungs, in the air around us, in plants, and it is also found in some tasty beverages, right? Do you guys know that carbon dioxide is what gives soda pop its bubbles? Yeah. So, has anybody ever accidentally or on purpose shaken up a can or a bottle of soda and then opened it? Yeah? What happens when you do that? It explodes. That's right. So the reason that happens, so soda, before you shake it up, right, it has a surface. It has something called surface tension. Those liquid molecules are kind of attached to each other. And it's keeping all of that carbon dioxide gas down. And when you shake it up, you break up those bonds. You break that surface tension, and the gas is free to explode up out of the bottle. Now, we could shake these up and then open them, right? But I would rather do this the Kentucky Science Center way. We are going to learn something from this. We're going to do an experiment. Now, has anyone ever seen one of these demonstrations where you use a type of candy to create an explosion? Yes, do you know what it is? How about you? How about you? Go ahead. Mentos, that is correct. We are going to use some Mentos. And we are actually going to do an experiment. We're going to compare two types of Mentos. Now, this is interesting. The reason why that Mentos creates such a great explosion is because the surface of these Mentos, it looks smooth. But if you look at it under a microscope, it's actually more like a golf ball. They have all these dents in them. And those dents are called nucleation sites. And what happens is, when those drop to the bottom of your soda bottle, all of the gas goes down and lands at those little nucleation sites and sends all that liquid flying up into the air. And that is how you create the Mentos geyser. Now what I want to do here is compare. I want to know which flavor of Mentos, the mint or the fruit, creates a better geyser. And what we have here is a picture showing what those nucleation sites look like on either of those flavors. So I want to ask you guys, which one do you think is going to have the best geyser, is going to go the highest? Yes, sir. The Mentos? Yeah, which flavor though? Which one? Yes.
The mint.
You think the mint? How come?
Because it has more of...
Oh, I see what you're saying. The mint one has more nucleation sites. Okay, who agrees, thinks that the mint is going to go higher? Okay, and who thinks that the fruit one might go higher? All right, so we are going to find out. And the way that we find out for sure is by keeping everything else in our experiment the same. The only thing that is going to be different between our two tests is going to be the flavor of the Mentos. Each of these devices are exactly the same. They have the same number of Mentos in them. And I'm going to use the same size and brand, even batch of soda to compare them. So there are no other variables that could confuse our results. So let's go ahead and give this a try. We'll start out with the fruit, since the mint is the one we think is going to be the best. So we'll open that up. We'll get our fruity Mentos on there, nice and tight. All right, now after I do this, you guys got to remember how high the geyser goes so that we can compare it to the mint. Okay, ready? In 3, 2, 1. Oh, well that wasn't a very good geyser at all. That barely even shot into the air. But what we can tell is how much left the bottle by looking at how much is left, right? So there's still quite a bit left in there. Let's give it a try with the mint. All right, let's get that loaded up. Oops. Get that on nice and tight. We'll see if this one does any better in 3, 2, 1. Ooh, all right. Well, maybe those sodas were a little flat to begin with. Did that one go a little bit higher? Yeah, it went a little bit higher. Okay, so it turns out we found evidence in support of our mint Mentos hypothesis. Now, in order to know for sure, we'd have to repeat this experiment. And I can tell you guys from experience, I've done it about 100 times. About 70% of the time, the mint one does go higher. And now, the other 30% of the time, though, the fruit one goes higher, and I do not have a good explanation for that. So if anybody wants to do some of these experiments at home, outside, mind you, let me know what your results are. Okay, let's review. When we burn coal, open a can of soda pop, react vinegar and baking soda, we are releasing what gas? Yes. Yes, carbon dioxide. 2 more elements on our map. All right, you guys, we are getting closer to finding the lost castle, but I think we need to speed things up. We are going to head to Europe to visit the Cavern of Catalyst, okay? Let's get those biplane wings ready, and here we are at the ruins of the Cavern of Catalyst, going deep underground. Oh my gosh, it's so scary. I hope there aren't any traps out here. Ah, trap. Okay. Gets me every time. Okay, here we are in the Cavern of Catalyst, and we are going to learn about the decomposition of doom. You guys notice there's a lot of doom in this adventure? I'm not sure I'm loving the amount of doom happening here. All right, so for this next one, this is one of the potentially dangerous experiments I'm going to do. So I'm going to put on my safety glasses, and my gloves. Now remember, anytime you see a scientist putting on gloves, you know something fun is going to happen. All right, let's get this whole setup right here. Now, we're going to see some familiar compounds up here in this chemical equation here. We've got H2O2, hydrogen peroxide. Remember we mentioned that at the beginning. We've got water, H2O, and we've got oxygen. So right here I have my hydrogen peroxide. I'm going to pour a little bit of it out. All right, now this hydrogen peroxide is a clear liquid. It looks just like water. So should I assume it's water? Or that it's the same as water? No, definitely not. Now, remember I said there's no such thing as a little bit different in chemistry. Now, that extra oxygen makes it a very different compound. Now, who here has ever heard of hydrogen peroxide? Some of you, a lot of you, right? You probably actually have some of it in your home. You might have had a grown-up put it on your cut or a scrape that you got. It bubbles, it burns a little bit, it cleans germs out of your cut. Now, what you have at home is 3% hydrogen peroxide. This stuff is 10 times stronger than that. It is 30% hydrogen peroxide, which is why I'm wearing all this stuff. It would burn my skin. I definitely don't want to get it in my eyes. And it would even turn my hair white if I got it in my hair. So it is definitely not water. But, I'm going to pour it into my flask here. Hydrogen peroxide can turn into water through this process called decomposition. So this is actually happening right now inside of my flask. Little by little, some of those oxygens are breaking off, coming together to form oxygen gas, floating up out of that flask and leaving behind water. And we can watch this happen. You guys aren't doing anything for the next 2 or 3 months, right? You're gonna hang out and watch the decomposition of doom? No? All right, well luckily, science has a way to handle this. We can use something called a catalyst. You guys say that word? Catalyst, let's put it up here. A catalyst is something that chemists use to speed up a chemical reaction. So in this case, we are going to use a chemical called copper chloride. And all this is going to do is, instead of taking a few months for this reaction to happen, it's going to happen in a couple of seconds. So, first though, we're going to add one more thing. We want to be able to see this reaction take place. And can you normally see oxygen gas? No, right? It's invisible. It's in the air around us. We don't see it. So I'm going to add this soap in order to capture that escaping oxygen, and we're going to see that now as foam. So let's squirt in some of that soap, mix it all in with our hydrogen peroxide so we can see the reaction take place. Now I'm going to measure out some of my copper chloride. There we go. All right, and to review, we've got hydrogen peroxide and soap in this flask. We are trying to turn the hydrogen peroxide quickly into water and oxygen that we're going to see as foam. You guys ready? Yeah. All right, help me with the countdown. In 3, 2, 1. Whoa! Whoa, look at that. Okay, that definitely didn't take a couple months, right? Now, in the biz, we call this experiment elephant toothpaste. Because, right, the copper chloride is green, it ends up with this kind of stripe in it, and it's this huge tube thing that looks like toothpaste only an elephant could use. Now, the reason it has that brown stripe is because this process released heat. Did anybody notice the steam that was coming off of this? Yeah. So this is called an exothermic reaction. Can you guys say that?
Exothermic.
Awesome, that's right. And so some of that foam got burned. And that's why if you smell something kind of funny, that's that burned soap that we're smelling. So that was pretty cool. Now we have learned all about catalysts. And let's review really quick. Catalysts to make things go faster. a metal that placed iron with a bronze color, this element seems to turn up like an old penny. What am I talking about here? Yes. Ooh, it's not bronze, it's copper. So that was our catalyst, that copper chloride. So that's another element we've got right there. And you guys, I think we have found enough information to head to the lost castle of chemistry. So let's get those biplane wings ready. We are going to head down there. We've done it by putting our elements on the map. We have discovered the location of the lost castle of chemistry. And there it is, rising in the distance, looking suspiciously like the PPG building in downtown Pittsburgh. And we are climbing up, scaling the side of it. We've learned so much about the elements. We can finally meet the kings of the castle and plant our flag. Now, that map that we had, we've got it right there. That is actually the periodic table of elements. It is a map of every element that scientists have ever discovered. And it's actually organized in a pretty interesting way. All the lightest elements are at the top, and the heaviest elements are at the bottom. And actually the columns and the rows also have some interesting things in common that you guys will learn when you get to your chemistry classes. Now, who's at the very, very top? Who are the kings of the castle? Does anyone know their names? Anyone? They are, yep. Nope, oxygen is just below. Is definitely a part of the royal court, but not the kings. The kings are hydrogen and helium. Now, they are the lightest and the most abundant elements in the universe. So let's see what we can learn about the kings of the castle here. So this is King Hydrogen, and King Helium is over here. We are gonna introduce ourselves to them in just a minute. Now, let's see what we can learn about them. So they're both currently a gas, right? They're a clear gas. They're lighter than air, right? Because they're floating up like this. They look and act the same. So should I assume that they're the same thing? No, that's right. You guys have been paying attention. We have learned today that we can't always trust our eyes when it comes to chemistry. We had the cheese candle. We had the hydrogen peroxide that did not behave like water. And so we should not assume that these two kings have the same temperament. So when I introduce myself to them, I'm going to start by introducing myself to King Helium. I am going to use my world famous chicken stick to say hello. Now, if anybody doesn't like loud noises, now is a good time to cover your ears. Let's see if King Helium can act as fuel in the fire triangle. All right, in 3, 2, 1. Whew. Okay, that wasn't so bad. You guys think the same thing's gonna happen when I say hi to King Hydrogen? No? All right, let's see about King Hydrogen, if he can act as a fuel. All right, chicken stick activated. Help me out with the countdown. In 3, 2, what you guys, I'm scared. Are you sure I should do it? Should I do it? Yeah? All right, okay, we'll do it this time. Ready? 3, 2, 1. Was it something I said? All right, you guys, I'm so proud of us. We found the lost castle of chemistry. We discovered all the elements. Let's patch back to the lab and hear what they have to say.
Our journey today is complete, but your adventure in chemistry is just beginning.
You've uncovered a map for future exploration.
A periodic table of the elements.
A collection of building blocks from which we can create new medicines and technologies. But as you've seen, science is much more than just a collection of facts.
Science is a way of thinking. Imagination is at the heart of every new discovery. By studying chemistry, you can do more than just uncover the past.
You too can be a catalyst to build a brighter future.
Awesome. Okay, you guys, that is the show. Thank you so much for doing science with me. Please come visit me at the Kentucky Science Center and have a great rest of your evening.
Hi, I'm Cindy Vows, the Library and Media Specialist here at Vine Grove Elementary, and tonight we've had a fantastic turnout for our Family Enrichment Night here at the Book Fair and at our school, and we are happy to be able to promote literacy at Vine Grove Elementary.